Okay, we're gonna get started. So, hello everyone, and thank you so much for coming to our workshop. My name is Sarah,
I'm Wendy.
and we are from Machine Learning Data Science Club at UT Austin, and we'll be giving a workshop on an intro to machine learning with scikit-learn. So just to go over a brief overview of what we'll be talking about today. So first, I'll give a brief overview of what machine learning is, and then we'll talk about supervised and unsupervised learning. And then we'll talk about scikit-learn, which is a really popular Python library for machine learning. And then we'll be going over our demo so you can see like how we use scikit-learn to implement these models. And then we'll go over some like common resources if you want to learn more about it. So first, I'll be talking a little bit about what machine learning is. So machine learning is a subfield of computer science where essentially you're trying to enable computers to learn from data and make decisions or predictions without being explicitly programmed to do so. So I'm sure we're all familiar with like how to like write a program, right? Like when you have a problem, you want to write a function, you kind of like program the exact steps it takes to solve a specific problem, and then the computer can like do that as needed. But when it comes to machine learning, you're essentially giving it data instead, and you're having this computer learn to pick up patterns from that data and then make these decisions and predictions without you having to like explicitly write it out. And so there are different subfields of machine learning. There's supervised machine learning, unsupervised machine learning, and there's reinforcement learning. So we're not going to talk about reinforcement learning in this presentation, but we will go over supervised versus unsupervised learning. So first, we'll talk about supervised learning. And so supervised learning is essentially when you're giving the computer a labeled training data set to teach the algorithms to recognize patterns and predict outcomes. So for example, if you wanted to train a model to, classify an image as either like a dog or a cat, you would probably train it using a data set where each data point is labeled as either dog or cat. And from there, the model can look at the different attributes you give it and look for these patterns that will either classify it as one or the other. And so supervised learning can also be subdivided into classification and regression. So classification is when you're trying to, I guess, give your like a data point like a class label. So for example, the dog and cat data set, that will be classification because it's either going to be a dog or a cat. But then for regression, regression is used when you're trying to predict a numerical value from your model. So I think a common example is predicting housing prices, right? Because you're trying to predict like a numerical like price value given like a bunch of data on different attributes. And so next is unsupervised learning.
So for unsupervised learning, you're basically dealing with unlabeled data. And some techniques that you can work with unlabeled data are clustering, which is essentially groups similar data points to find patterns, and dimensionality reduction, which simplifies data by reducing the amount of features. So for dimensionality reduction, it basically fastens the process and makes it more efficient when working with the models. And for this is just the general idea of the visualization that you can use when using clustering and dimensionality reduction. And this is just a general overview of the supervised and unsupervised learning and the paths you can take depending on the data that you're working with.
So now we're going to talk a bit more about scikit-learn. So as I said before, scikit-learn is a really important Python library for machine learning. I would say it's probably like one of the most used. And so if you really want to do anything with machine learning, it's really important that you know like how to use like scikit-learn. So you can use it for basically the entire process of implementing a model. So that goes from like data pre-processing. You can implement like supervised learning and unsupervised learning. And once you have your model trained, you can also use it for model evaluation and model selection. So we're going to go over like a quick demo that we made just to give you guys an idea of how to, or an example of how you would use scikit-learn. So if you go to this tiny URL, you can access our Google Colab document. So I'm going to give you guys a second to just type that in before I go to the demo. Okay. Does anyone still need, can I switch my screen? We good? Okay. Okay. Or should I switch it?
Oh, do you still need more time?
Okay,
Okay.
okay. So I'm gonna switch my screen now to our demo. Um, so I'm gonna go over it relatively quickly, and you guys can definitely look at it on your own if you want to use anything or need to see it more in depth. But just give you a quick overview. So first, we are importing all the necessary libraries that we need for this notebook. So as you can see, first we have like pandas, numpy, matplotlib, seaborn. These are all really common for like data manipulation and visualization. And the rest of all these imports are all from scikit-learn. Um, Everything from like implemented models to model evaluation. So once you've imported all of those libraries, you can load your dataset. So in this demo, we're using the Iris dataset, which is a very popular machine learning dataset for beginners. And we're actually loading it from scikit-learn directly, which is pretty convenient. And so once you load the dataset, we're splitting you can split the data into the features and the target labels. So in this case, this data set is actually, it consists of like 150 samples of iris flowers, and the species is the target label in this case. So in this case, Y would be the target label, species, and X would be the rest of those features. And from there, we're splitting our data set into training and testing sets. And so we're using like an 80-20 split. So 80% of that data will be used for training and 20% will be used for testing the model once you've trained it. I forgot to run this. I'm gonna run it real quick. But yeah. So once you've loaded their data set and split it, next will be data pre-processing. And so one really important thing you should make sure of doing when you're loading your data is to check for any missing values. Because obviously if you have those missing values, if you don't like handle them in some way, they will like affect the accuracy of your model pretty significantly. And in our case, Iris actually doesn't have any missing values because it's already pre-processed, but yours might. And then once we check for those missing values, we also scaled our features. And this is important because a lot of models like they perform a lot better if you like scale them first. So in this case, we're using standard scaler, which I believe that scales your data so that the mean is 0 and the standard deviation is 1. So I'm gonna run that. And so now that we've pre-processed all that data, now we're moving into like, implementing these actual models. So first we split it up into supervised and unsupervised learning. So I'm going to go over the supervised learning part first. And as I said before, supervised is all about making predictions or decisions based off of a labeled training data set. And so first we're going to look at some classification models. So this is definitely not an exhaustive list of all the different classification models that are out there. Um, but yeah, so first is a decision tree, and this is a model that essentially splits the data into branches to make decisions. And so as you can see, it's really easy to implement using scikit-learn because first in this first line, we're first initializing the classifier, which is the decision tree. And once we do that, we're fitting that tree to our training data. And once we fit it, then we're able to make predictions using the test data set that we created before. And so once you've done that, you can also we've provided examples of how you can evaluate your model. And so we've provided examples of how you can calculate your accuracy score, your F1 score, and create a confusion matrix. So in this case, our accuracy is 100%, which because we're using the Iris data set, but yours may not be. And so you might have to tinker with your model a little bit based off of like what stats you're getting off of that. And this is also some code for you to visualize your confusion matrix that you made. So I don't know if you guys are familiar with confusion matrices, but on the y-axis we have like the true labels, and then on the x-axis we have the predicted labels. And as you can see, since our accuracy is 100%, we have like, like zeros everywhere, and then 11, 13, 6 on the diagonal. And moving on to the next model is a random forest, and it's like the almost the same process for like implementing it and training it. So I won't go over that, but that's right here. And again, these are also like just more examples of how to calculate accuracy, F1, and confusion matrix. And we've also provided an example for a support vector machine. So this is a type of model where essentially if you envision that all of your data points are plotted on like an XY plane, you're trying to find like a hyperplane to like best divide those points between like different classes. And so this is also pretty similar in terms of how to implement this. Initializing the model first, then fitting on your training data, and then making the predictions. And next, we've also included k-nearest neighbors. So this is also a model where you have you look for you plot like your whatever your input data point is, and you look for the k-nearest neighbors, the points around it, and based off of like a majority vote system, that's what you're going to classify your point as. And again, these are also the same like accuracy scores that we used before. And again, another example of a confusion matrix. So now moving on to regression. Again, regression is when you're trying to predict a numeric value from your data set. And I think the most like common, or at least like the one that you learn first, is always linear regression. So this is when you have like all your data and you're trying to plot a linear line that would like a line of best fit through that data. And so again, like very similar way of like creating them all, fitting it, and running predictions on it. And here we've also included some more evaluation metrics. So we have mean squared error, mean absolute error, and R squared. We've given a description of like what each of these like means. You can look through that on your own, but just some more data to look at. Yeah. Do you want to do unsupervised?
Yeah.
Okay, do you want to mind super scroll?
So for unsupervised learning, once again, it's mostly like making predictions and decisions based on unlabeled data. And for this first technique, it's clustering. So for k-means, it's essentially just grouping the data into clusters based on the similarities. And here we would start off with like grouping the data into the three clusters, and then fit the model into the data, and then those labels assigns each data point to a cluster. And for model evaluation, we use the within cluster sum of squares, which measures the compactness of the clusters, and lowers values indicate in tighter clusters. So for here, it initializes it with I clusters, and then it trains the model, and then it appends the inertia, which is cluster tightness to the list. And then so inertia is basically just like the sum of square distances to the nearest cluster center, and it collects WCSS to find the optimal cluster count by plotting them. So as you can see here, we use the elbow method, which graphs the WCSS to determine the optimal number of clusters. And here you'll have to determine the bend part of the plot, which also it doesn't necessarily mean that adding more clusters significantly reduces the WCSS. So here is the elbow method, and this is the vertical line at the elbow point that determines the optimal number of clusters. And here is the silhouette score for clustering quality. And here's basically looks into the labels and prints them. And as you can see here, the silhouette score is of 0.55, but the score ranges from -1 to 0. So since it's kind of closer to 1, it kind of determines it into like a well clustered and far away from the other clusters, instead of like the data point being likely assigned to a wrong cluster. As you can see here in the visualization, it's on the x-axis is the sepal length, and on the y-axis is the sepal width. And you see how it's divided into groups. So now into dimensionality reduction, uh, we we are using the principal component analysis, the PCA, which reduces the number of features while keeping the significant information in the variance. And basically, it's just for easier visualization and makes data easier to work with, and it's faster and more efficient machine learning models. So as you can see here, it creates the object with two components and fits the model into the data, and then it transforms it into the new principal components. And here's the visualized transform data in which it gets the column of the first column and then on the second one. And here CMP is basically like the color map. And yes, on the x-axis is the first principal component, and in the second one, which is the in the y-axis, the y principal component. And it's just basically like once again to make the data easier to work with and the models to be more efficient and faster to work with.
So yeah, that was our demo. And now we can go back to our slide deck. Yeah, yeah, sure. Oh, the
There's
link. Yeah, this one.
yes.
Okay. Okay.
So you guys may be wondering, so what are some real world applications? And of course, there's a lot in a variety of fields, as you can see here. On healthcare, it's like the diagnosis of diseases, the predicting patient outcomes. For finances, like risk assessment, fraud detection. For marketing, is customer segmentation, the price optimization. And for media, it's content recommendation. So for example, like on TikTok, you sometimes see like those oddly specific TikToks, videos, and also like on Instagram Reels. Those are the machine learning models working, and also audience analysis.
Your For You page is basically machine learning.
Yep.
Yeah.
And here are some resources if you want to look further into like scikit-learn. There's also like a cheat sheet and stuff that goes more into depth into machine learning and also into Python and pandas.
Thank you guys so much for coming to our workshop. So in the demo, I linked the slide deck at the very top, so you can access the slide deck from the demo link, and that way you can access any of these links and stuff. And if you guys are interested in like data science, I highly encourage you to come to our meetings because we have workshops like these all the time, every week on Tuesday evenings. So, but yeah, do you guys have any questions? Oh, and will y'all please stay here for like a quick 2 minutes? I'm just gonna make sure that we get raffle tickets to you all so that you can get those prize machines. Keep going. Oh,
What's the previous slide about the benefits of using this site paper?
Mhm.
It's also about the content, yeah, like the slide with the across the
Is this slide?
like after a couple of slides later on. Yes.
This one?
The Google application. So one of our benefits really utilizing the media in which we're doing a recommendation for a content that in the gaming world. So how would this like how would the, the model of the scikit learning, like how do we use it to implement into our development system, like because if we have like the front end programming like the merge and then also the, the Python programming of the Cola is the one that could run the scikit learning, and how do we implement that into the system that we are building? So,
Um, I would say it's a pretty tough question to answer just because, obviously I don't know the specifics of your project. Um, I will say that um hmm, I know that like for companies that have like real like content recommendation systems, they also have a system to like collect data like as the user is using the app, if that makes sense. So I would say you might have to just do a bit more research on how to implement that because I think like based on what you're saying, like you're kind of looking for that kind of system where it's like as I use the app, you're collecting my data, and from there the model will like push me more data, right? So honestly, I wish I could like give you like more help, but I think without knowing that much, I would say just like look into like ways to like first of all collect data from the user and then like pre-process that data and then try to look into like what kind of model you want to use that you think would best fit like your use case because obviously we went through a lot of different types of models you could use, but they might not all be useful for like your project, right? And another thing I would suggest is maybe using like looking into models that are already pre-built online because a lot of them have like APIs that you can just connect to, and that might be easier than like building a model from scratch. So many options. But yeah, I'm sorry I couldn't help more, but you know, just different things to look into, I guess.
Those Tuesday meetings.
7 to 8 in the EER, which is the engineering building. But yeah, join our Discord if you want to come. We post like announcements in there and stuff.
Can you put the website URL back up?
Yeah. And again, like you can access these slides from like the demo link. I linked it at the very top too. So
You're right.
no, you're good. You're good. You guys have any more questions? All right. Well, thank you guys for coming again. And if you have any more questions, you can like come up and we'll still hang around here.
Yeah, thank you so much, guys.
What have you done?